All right. Let's deep dive into something pretty mind-bending.
Okay.
This research paper.
Oh, yeah.
Proposing this wild idea
Mm-hmm.
called natural language reinforcement learning.
Yeah.
NLRL for short.
Right.
Basically, it's about teaching AI to learn more like we do,
Okay.
using plain English
Uh-huh.
instead of all that complicated math.
It's a fascinating departure from traditional reinforcement learning,
Yeah.
which, while effective,
Yeah.
can be a bit of a black box.
Right?
We see amazing results,
Yeah.
like AI mastering Go,
Uh-huh.
but often
Yeah.
don't fully grasp the how.
So instead of just number crunching,
Right.
this NLRL is all about bringing language into the mix.
Yeah.
I'm intrigued, but also a bit skeptical.
Sure.
Can you really teach AI to think in words?
That's the central question
Right.
the researchers are grappling with.
Yeah.
They argue that using language
Uh-huh.
could not only make AI more transparent,
Okay.
but also unlock new levels of learning and problem solving. Think about it.
Yeah.
Language allows for much richer and nuanced feedback
Right.
than just a numerical reward.
Ah, that's an interesting point.
Yeah.
Instead of just good
Yeah.
move or bad move,
Exactly.
the AI could get feedback that's more specific.
Yeah.
Like that move opens up the center of the board,
Uh-huh.
or that weakens your defenses.
Exactly.
Yeah.
That kind of detailed feedback could accelerate the learning process
Right.
and lead to AI systems that are more adaptable and strategic.
Okay. Starting to see the potential here.
Good.
But how does this actually work in practice?
Sure.
Is this just theory, or did they actually build something?
They put their ideas to the test
Okay.
using games like tic-tac-toe,
Mm,
maze navigation,
okay.
and a strategy board game called Breakthrough.
Right.
Games offer a controlled environment
Yeah.
to experiment with these
Flip
concepts
sets.
before diving into the complexities of the real world.
So they're basically using games as a sandbox
Mhm.
for this new AI paradigm. Makes sense.
Yeah.
But walk me through NLRL itself.
Okay.
What are the key building blocks?
At its core, NLRL takes the fundamental elements of traditional reinforcement learning,
Right.
things like rewards and decision-making,
Okay.
and reimagines them in terms of language,
Uh-huh.
for instance.
Yeah.
Instead of receiving a numerical reward for reaching a goal,
Okay.
the AI might get feedback, like you
Uh-huh.
reached the goal.
In essence, they're creating a system where the AI's thought process is,
Right.
to some extent, visible and understandable to us through language.
Precisely.
Okay.
And the paper explores different roles
Yeah.
that large language models,
Right.
or LLMs,
Uh-huh.
can play in this framework.
Okay.
For example,
Yeah.
LLMs can act as language policies,
Right.
which are essentially the AI's inner voice,
Okay.
strategizing in words to choose the next move.
So the AI is actually thinking through its moves in a way that's closer to how humans
the idea.
might approach a problem.
It's moving away from opaque algorithms towards something more interpretable.
Right.
Then you have language value function approximators,
Okay.
which are like AI commentators,
Right.
analyzing the current state of the game
Uh-huh.
and providing insights in plain English.
So you have the language policy making the moves,
Right.
and the value function approximator assessing how good those moves are,
Exactly.
all using natural language.
Yeah.
What ties this all together?
That's where distillation comes in.
Right.
It's the process of using those language-based evaluations
Yeah, right.
to actually train and improve the LLM's ability to play the game.
So it's like the AI is learning from his own commentary and analysis,
That's a great way to summarize it.
gradually refining its strategies
Yeah.
and becoming a better player.
Yeah.
This is fascinating stuff.
Yeah.
Okay.
It is.
They've got this framework,
Right.
but did they actually see any positive results?
They did.
Okay.
And they focused on 3 specific applications of NLRL. First, they looked at how NLRL could boost an LLM's existing capabilities
Mm-hmm.
through clever prompting.
All right.
Imagine giving your AI chess player some expert-level tips before a match,
Okay.
significantly improving its performance
Right.
without retraining the entire model.
That's pretty impressive.
Yeah.
What were the other 2 applications they explored?
They investigated training a natural language value function from scratch,
Okay.
essentially building that AI commentator from the ground up.
All right.
And finally,
Yeah.
they developed a full-fledged natural language actor-critic learning system
Okay.
where the AI agent
Uh-huh.
both strategizes and evaluates its actions using natural language.
So a complete loop.
Yeah.
where the AI is thinking,
Yeah.
acting, and
Right.
learning through language. Give me some concrete examples.
Freedom.
Do they actually see this working in those games?
They did.
Okay.
For instance,
Yeah.
in the maze experiments, they found that simply prompting the AI with better ways to evaluate its options using language
Right.
significantly improved its performance.
Wow. So just giving the AI better language skills actually make it a better problem solver.
It did.
That's incredible.
Yeah.
What about those other games?
In the breakthrough experiments,
Okay.
they were able to successfully train a language value function
Uh-huh.
that could accurately predict which side had the advantage in a given game state.
So their AI commentator was actually pretty good at analyzing complex game situations,
Exactly.
just like a human expert might.
Yes.
That's wild. So they've shown this can work across different types of games.
Right.
I'm starting to grasp the potential of NLRL.
Good.
But I also have a ton of questions.
Sure.
What are some of the limitations?
Yeah.
Where could this research lead?
Right.
And could we see this applied to real-world problems beyond games?
Those are all great questions.
Right.
And we're going to dive into them in just a moment. Stay tuned.
All right. So we left off with some pretty big questions.
Yes, we did.
About the limitations
Right.
and the future
Yeah.
of NLRL. So let's start with those limitations.
Okay.
What were some of the things that tripped them up?
Well, one of the biggest limitations right now
Okay.
is that their experiments
Uh-huh.
primarily focused on environments
Right.
with a limited set of possible actions,
Yeah.
like choosing moves in a game
Hmm.
and states that could easily be described with text.
So those maze games and board games fit the bill perfectly.
Yeah.
But applying this to the real world,
Right.
where things are more dynamic and less predictable,
Yes.
would be a whole different ballgame.
Exactly.
Right.
Imagine trying to control a robot arm
Oh,
with all its subtle movements or navigating the complexities of the stock market.
Right.
Those scenarios would be much harder to represent with just text.
I can see how that would be a huge challenge. What about the computational resources required for all of this?
Yeah.
I mean, we're talking about using LLMs,
Yeah.
which are notoriously demanding.
That's another key limitation.
Right.
Their experiments were done on a relatively small scale
Okay.
because running these language models,
Right.
especially for complex tasks,
Yeah.
can be very resource intensive.
Right.
Scaling this up to real-world problems
Uh,
would require some serious advancements in hardware and software.
so it's a technological hurdle,
Yes.
but not necessarily a fundamental limitation
Exactly.
of the NLRL approach itself.
Exactly.
Okay.
And the field of AI is constantly evolving.
Right.
New hardware and algorithms are being developed all the time.
Uh-huh.
That could make it more feasible
Right.
to run these large language models
Okay.
efficiently in the future.
So potentially solvable.
Yeah.
With more horsepower.
Right.
And smarter code.
Exactly.
Okay. Enough about the limitations.
Sure.
Let's talk about the future. What are some of the exciting directions that researchers highlighted for further exploration?
One area they emphasized
Okay.
is the need for a stronger theoretical foundation for NLRL.
Right.
Right now, it's largely based on analogies
Yeah.
to traditional reinforcement learning,
Okay.
translating those core concepts into language-based equivalents.
Mm-hmm.
But a more formalized mathematical framework
Right.
would solidify the foundation
Yeah.
and make it easier to apply to new problems.
So they're laying the groundwork for a whole new field of AI research.
Yeah.
What other future directions did they mention?
They talked about integrating NLRL with other areas of research,
Okay.
particularly those focused on self-evaluation
Mm-hmm.
and self-improvement in AI systems.
Right.
Imagine an AI system
Yeah.
that can not only learn from language-based feedback,
Right.
but also identify its own weaknesses
Wow.
and actively work to improve itself.
That's a pretty mind-blowing prospect.
And
AI
so-
that can learn. Right.
Adapt and
Mhm.
essentially bootstrap itself
Yeah.
to higher levels of intelligence.
It is amazing.
What else?
Another fascinating direction they mentioned is combining NLRL with research
Uh-huh.
on language model planning.
Right.
LLMs, as we discussed,
Yeah.
can act as language policies,
Uh-huh.
essentially using language to strategize and make decisions.
Right.
Integrating this with other planning techniques
Okay.
could lead to AI systems that are not just reacting to their environment,
Yeah.
but proactively pursuing goals.
So moving beyond just playing a game
Exactly.
to actually setting goals
Right.
and figuring out how to achieve them.
Yeah.
It sounds like all these future directions are pointing
Yeah.
towards a more human-like intelligence
Yeah.
where AI systems can think,
Right.
plan,
Uh-huh.
learn,
Yeah.
and even improve themselves
Right.
using language as their primary tool.
That's a really insightful observation.
Yeah.
And it highlights the transformative potential. Uh-huh.
Of NLRL.
Right.
It's not just about making AI perform better
Right.
in specific tasks.
Yeah.
It's about fundamentally changing how we design
Right.
and interact with intelligent systems.
So could we see this applied
I think so.
to real-world problems
Yeah.
beyond games?
The researchers believe so.
Okay.
They mentioned exploring applications in areas like reasoning tasks
Uh-huh.
and even code generation.
Okay.
Imagine AI systems that can help us solve complex problems,
Right.
write software,
Yeah.
and perhaps even gain a deeper understanding of the world around us.
The possibilities seem endless.
They do.
But I keep coming back to those challenges we discussed earlier.
Right.
How did the researchers
Yeah.
specifically address issues like hallucination
Okay.
and catastrophic forgetting
Right.
in their experiments?
Let's revisit those tic-tac-toe experiments
Okay.
to understand how they tackled these challenges,
Right.
remember? Their goal was to create a natural language actor-critic system
Mm-hmm.
that could learn to play tic-tac-toe effectively
Right.
using only language-based interaction and feedback.
Right.
And they encountered that issue of hallucination
Yeah.
where the language value function
Mm-hmm.
would sometimes make up evaluations
Right.
for board positions it hadn't actually seen before.
Right.
And these inaccurate evaluations
Yeah.
were hindering the learning process.
No.
To address this,
Yeah.
they introduced something called an action selection mask.
Oh, okay.
Essentially,
Yeah.
they restricted the language value function
Mm-hmm.
to evaluating only a subset of moves
Right.
that were likely to be chosen
Okay.
by the language policy.
So instead of letting the language value function go off on tangents
Exactly.
and evaluate irrelevant moves,
Yeah,
they focused its attention
Right.
on the moves that were most likely to be played.
precisely.
Right.
This helped reduce those nonsensical evaluations
Yeah.
and made the learning process much more stable and efficient.
That's clever.
Yeah, it is.
What about the problem of catastrophic forgetting?
Right.
How did they prevent the language value function
Okay.
from forgetting its past experiences as it learned from new games?
They employed a technique called experience replay,
Okay.
which is commonly used in traditional reinforcement learning.
Right.
Imagine a storage container
Uh-huh.
where you keep a record of all the important evaluations
Okay.
the language value function has made in previous games.
Right.
Periodically,
Yeah.
the AI revisits this container
Okay.
and relearns from those past evaluations,
Right.
preventing it from forgetting
Yeah.
those valuable lessons.
So it's like giving the AI a refresher course
It is.
to reinforce those past experiences.
Exactly.
That makes a lot of sense.
Yeah.
It's fascinating how they're adapting these techniques
Right.
from traditional reinforcement learning
Right.
to this new realm of NLRL.
It's a testament to the creativity and ingenuity of the
Right.
researchers.
Yeah.
They're combining insights from different fields
Right.
to create a truly novel approach to AI.
Uh-huh.
But speaking of revisiting past experiences,
Yeah.
I think it's worth taking another look
Right.
at how they evaluated their natural language value function in
Oh.
the game Breakthrough.
You're talking about those Monte Carlo simulations they use
Yeah.
to determine which side had the advantage
It's
their
different.
given board position?
That was a particularly clever technique,
Okay.
especially when you consider
Uh-huh.
the inherent subjectivity
Yeah.
of evaluating a game like Breakthrough.
Right.
Different human players
Mm-hmm.
might have different opinions
Right.
about who has the upper hand.
So how do you create a reliable benchmark for evaluating an AI system
Yeah,
that's supposed to make these kinds of subjective judgments?
that's where the Monte Carlo simulations come in.
Okay.
Okay, imagine you have a computer that's really good at playing Breakthrough.
Okay.
You can use this computer
Uh-huh.
to simulate a massive number of games,
Right.
starting from a particular board position.
So they're essentially having the computer play out
Yes.
thousands, maybe even millions of games
Right.
from each position
Yeah.
to see who wins most often.
Yeah, exactly. And by analyzing the results of these simulations,
Uh-huh.
they can get a statistically sound estimate
Right.
of which side is more likely to win
Okay.
from that starting position.
Right.
This provides a ground truth
Yeah.
against which they can compare the language value functions predictions.
It's like they're using the raw computational power of the computer
Yes.
to create a baseline for evaluating the more nuanced
Right.
and subjective judgments of the language-based AI.
Precisely.
Right.
And it's a great example of the rigorous evaluation methods that are essential for advancing the field of NLRL.
Right.
But, while we've been focusing on these specific experiments, I keep thinking about the broader implications of this research.
Me too.
Yeah.
It's easy to get caught up
Right.
in the technical details.
Yeah.
But the bigger picture is truly fascinating.
It is.
Right.
It's about more than just making AI systems smarter.
Right.
It's about making them more understandable, more collaborative, and more aligned with human values.
It's about bridging the gap between the way we think and the way AI operates, using language as the common ground.
Precisely.
And that's a powerful idea.
It is.
With implications that extend far beyond the realm of games.
For sure.
This NLRL research is definitely food for thought.
It is.
It raises a lot of questions.
Yeah.
It sparks a lot of ideas.
It does.
And I'm sure it's left our listeners with plenty to ponder.
I would hope so.
And we'll be right back.
Okay.
After a short break.
Right.
To explore some of those bigger questions.
Sounds good.
And leave you with a final thought to chew on.
Okay.
Stay with us. We're back and ready to wrap up our deep dive into NLRL.
It's been a fascinating exploration.
It really has.
Yeah.
And as we think about everything we've discussed, I think it's clear that NLRL has the potential to really shake things up.
Yeah, I think so.
In the world of AI.
Absolutely.
It's not just about incremental improvements.
It's a paradigm shift.
Yeah.
It really is.
It's about fundamentally changing how we design and interact with intelligent systems.
For sure.
And I think that's what makes this research so compelling.
Absolutely.
It's not just about making AI systems better at doing what they already do.
Yeah.
It's about expanding the very definition of what AI can be.
And how we can understand it.
Exactly.
Right.
So as we wrap up this deep dive, I want to leave our listeners with a question that really gets at the heart of those possibilities.
Sure.
It's a question the researchers themselves pose in their paper.
Okay.
If NLRL can achieve such impressive results in the controlled world of games, what might it be capable of?
Yeah.
In the messy, complex, and often unpredictable realm of real-world problems?
That's a big question.
It is a big question.
A lot to think about.
And I don't think there are any easy answers.
No, not at this point.
But that's what makes this research so exciting.
It is.
It's opening up new avenues of exploration, new ways of thinking about the relationship between language and intelligence.
Absolutely.
And who knows what breakthroughs.
It's exciting.
Might be just around the corner.
A lot of potential there.
Well, it's been a pleasure.
Yeah, likewise.
Diving into this research with you.
Thanks for having me.
And to our listeners, thank you for joining us on this journey into the mind-bending world.
It is mind-bending.
Of natural language reinforcement learning. Absolutely.
Until next time.
Yeah.
Keep exploring.
Just stay curious.
Keep questioning.
Yeah.
And keep imagining the possibilities.
I like that.
All right.